Proceed. Okay, good morning. So, as I told you, today also I will continue teaching. So, what we learned in the previous session was what was about primitive functions. What do we mean by a primitive function? If I give you a function little f, capital F is called a primitive function for the little f. If you differentiate a capital F, it becomes the little f. Yes? So that was the definition of a primitive function. For example, if I tell you f of x equals to 5x squared, then this is a primitive function for the function 10x. Why? Because if I differentiate this capital F, it becomes the small f. And we also learned that this is not the only function whose derivative is this, but other functions are not that different. They can at most differ by an additive constant. So that's why if I ask you find all primitive functions of this, as soon as you get one, technically you have found all of them by writing a constant c at the end. That would be the whole set of functions whose derivative is equal to 10 of x. It is not a trivial fact, but you need to have my words on it that is correct. So you have to prove it. But anyway, so if you find one, that is enough. And then I told you that more or less the logic, you might say why we are interested in doing things. I told you that for the time being, just keep it like a mathematical curiosity, and then later we will see what are the applications within mathematics and other parts of science probably. What we want to do today, okay, by the way, do you remember I told you that this lesson is very similar in spirit to the derivative. For the derivative, you had a table for derivatives. You also have here a table for primitive functions. But here I write f, here I write capital F. Up to here, we have only two rows here. One row was, do you remember, for a constant function? If I give you a constant function and I ask you what is a primitive function for that constant function, I'm asking you give me the function whose derivative is number k. Of course, it is clear that that function should be k times x, but because of this that I explained, in principle, if you are interested in all of them, you put a constant there. And then the next problem we solved was what happens if I ask you what is a primitive function for x to power a. We also learned about that, and then I solved some problems, even A-level problems considering this formula. So do you remember what was it? It was 1 over a plus 1, x to the power of a plus 1, and then plus an additive constant c. And of course, immediately you see that this formula does not work if a is equal to minus 1. So that is crucial to emphasize that this will work for all values of a, even fraction powers, even square root powers, except this special case where a is equal to minus 1. What happens when a is equal to minus 1? It becomes the topic of math 4. Yes?
Would the formula still work if you put in an imaginary number?
No, imaginary number is completely different because then we have to define what do I mean when x goes to power I.
Okay.
Yeah. So today I want to complete this table a little bit more. So another function that I want to add to this table, I have already given you examples of this kind. So let us just not spend time on it. And now we go to the next function. If I give you e to power just x, and I ask you what is a primitive function for e to power x, what's the answer? Yes?
E to the power of x.
E to the power of x, because e to the power of x is the function whose derivative becomes equal to. But if I increase it to e to the power of kx, then what is the answer? If I put a constant also for the exponent. a constant k, yes?
And then the constant goes to the front, and then it repeats itself?
No, that is the differentiation rule, so you shouldn't confuse. If I ask you take the derivative of this, yes, you are right, k goes down and then the function repeats itself. That is the differentiation rule. They are very connected, closely connected, but they are not the same thing, yes? If I ask you differentiate this, a goes down and you have to subtract 1 unit. Here you are adding 1 unit because you are, I told you that the primitive function, finding the primitive function process is the reverse process of differentiation, so you shouldn't get confused here. So what is this one? You need to tell me a function whose derivative is this, not differentiating this.
The same?
The same is more or less true, but not 100%, because if I ask you
Plus c?
this, you get, no, it's on the board. So plus c is, forget about this. This is not correct yet. Because if I ask you what is the derivative of this, it is on the board. The derivative is k times e to power kx.
1k.
So yes, you have to anticipate that what is going to happen if I factor. Then k will come down. I have to get rid of that k because I do not have any k's here. To anticipate this, I put 1 over k so that it cancels that k that comes here. So now if I ask you what is the derivative of this, what is the derivative of this? This 1 over k is a constant, so I just write it down. And then I have to differentiate this part. According to the differentiation rule, k goes down and the function repeats itself, yes? But then what happens? This k, 1 over k that I have put here will cancel that k that is coming down, and what is left for me is e to the power of kx. So it means that I was able to find a function after differentiation gives me this function. So this is a primitive function. And then of course if I ask you for all primitive functions, you have to put a constant c out there, yes? There is also one thing, if you remember, in our table of differentiation, I also told you a formula for this exponential function. What was that, do you remember? K goes down, function repeats itself, but it is not finished. You have to multiply by ln of a as well. Now, the point is that I want you to give me a formula for a primitive function for this. Meaning that, give me a function so that after differentiating it, I get this function back. Hopefully, by the same spirit, you can realize that this should be more or less the same function. But I have to fine-tune it because if I tell you this is the answer, this is not 100% correct. Because if I ask you to differentiate this function, of course you will get a to the power of kx that you need, but you also get 2 extra pieces, yes?
1 over k ln of a?
Yes, so you have to divide not only by k, but also by ln of a. Yes? This k and this ln of a that you intentionally put here will definitely cancel these 2 extra pieces that you don't need. And then for the time, you'll put a c here. Yes? So these are the only formulas that you have in Math 3C. And then today I want to talk a little bit about some examples for this, and I also want to give you the lesson for the next section, which is related somehow to this C. And by the way, so far I have given you these ideas, and that we can talk about O, we can talk about E, we can talk about the primitive function, yes? Okay? And then today, you already know about this and that. If I say all, it means that I am asking you to show respect and put C there, yes, to acknowledge that. If I ask you a primitive function, you can choose whatever you want for C, but the simplest choice is 0, so this means that we don't even care about C. And there will be the topic of the next lesson that I will tell you. But before that, let us solve some problems, a mixture of these. This table will be given to you in the formula sheet, and the differentiation formula is also given to you. And they are very closely connected and they look like the same. So be careful not get confused, because I have seen students use the wrong table for answering the questions. Okay, so let me just start writing an example here for you. If you remember, in the previous example that I solved, I asked for all primitive functions. So if you don't mind, for simplicity, let us this time take a primitive function. So find a primitive function for the following functions. So, number one, f of x, let me make it simple, e to the power of 5x. So what is a primitive function for this one? You go to this table, and then you see that, yes, this function is here, but 5 is playing the role of this k. So I don't need to change anything at all. I can simply write the capital F right away. What is the answer? 5 does not go down. When it is primitive function, 1 over 5 goes down, and the function repeats itself. And then, do I need to put a C here in this problem? No, because they have asked about a primitive function. That's it. And if someone asks you what you have done, you would say that I found a function, so that when I differentiate it, it becomes this function. So number two. So number two, so what do you think about this one? E to the power of x plus e to the power of minus x. We want to find a primitive function for this function. Okay, if you remember the previous lesson, in the previous lesson I also wrote some, I don't know, heuristic notation. This notation is not, this is not standard at all, but I told you that if you want to find a primitive function for the sum of two functions, you can do primitive function for the first one plus primitive function for the second one, yes? And then I told you that that is the same thing if that's difference. And I also told you that if you have a constant, let me call constant k here, a constant k, and you multiply it by a function, and you want to find the primitive function for the whole combination, you don't do anything with k, and you just multiply it by the primitive function. And if you remember, because even I was correcting Math 4 paper, I see still people make this mistake. This is not correct, that this is the primitive function of f, primitive function of g. Yes? This formula is valid if I have addition and subtraction or multiplication by a constant number, not multiplying two functions. That is wrong. And primitive function of f over g, if you say it's primitive function of the numerator divided by primitive function of the denominator, that's also wrong. Okay, so now you see that I have the sum of two functions. And the sum rule works for primitive functions as well. So if I want to find a primitive function for this, let us say capital F of x, I need to concentrate here and here separately. Why this is possible? Because the operation between these two is addition, and for addition I can do that. So what should I do? I will find a primitive function for e to the power of x using this formula, but what is playing the role of k in this problem?
1.
1. For the next one, what is playing the role of k?
Minus.
Minus. So if you want, you can write 1 over k, the function repeats itself, plus 1 over minus 1, the function repeats itself. But 1 over 1 is just 1. You just simply write e to the power of e x, and this becomes minus e to the power of minus x. So a primitive function for this function is that. Yes? Number 3. So let us write f of x is equal to x squared plus 2 to the power of x. Okay, so here I can also use the sum rule. I need to concentrate on this and this, and then after finding each, I just add them. So x squared is not today's lesson, is the previous lesson, and here a is 2, yes? So I use this formula for the first part, so this becomes 1 over the number a plus 1, x to the power of number a plus 1. This is the previous lesson for the first part. But this one is today's lesson here. Yes? A is 2 in this case, and k is 1 in this case. So I use this table. So it becomes what? Plus 1 over k is 1 times ln of a, which is ln of 2. Yes? 1 over k ln of a. But the function repeats itself. So 2 to the power of x. And then, of course, it is better to simplify. 1 over 3 x to the power of 3 plus 1 over ln of 2 times 2 to the power of x. So that is the answer to this problem. So this is a mixture of previous lesson and today's lesson. So number 4, so f of x is equal to, for example, let me write e to the power of 2x multiplied by 1 plus e to the power of minus 3x and then to power 2. So in all cases so far, I have immediately started using the table because the functions are directly in the table. But this function is not directly in the table. It is of course composed of functions which are in the table, but not this combination. So what is your suggestion here if I want to continue and find this?
Expand.
We have to expand, yes? So by expansion, so it means that this blue, what I am writing in blue is part of the solution. You see that in all cases, I immediately start writing the capital F, but here I do not write capital F because I have to expand this. So I just write this here, and then I raise it to power 2 by squaring root. The first one squared is 1. 2 times the first one times the second one is 2e to the power of minus 3x. And the second one squared is e to the power of minus 6x. But the expansion is not finished yet. I multiply this term here. So this becomes e to the power of 2x plus 2e to the power of what? Do you remember this is e, this is also e. If I multiply, the bases are the same, so I have to add the exponents. But the exponent here is 2x minus 3x is minus x. So that is minus x. Okay, can you tell me what is the next? E to power? I multiply this here as well. What's the answer?
E to the power of negative 12x.
Negative 4x, yes.
Negative.
Because you have to add
Add
these two numbers,
for
yes. Okay, now everything is ready. So this function that I want to find its primitive function is composed as addition of 3 functions. All of those functions are of this form. So now I can write capital F of x equals to a primitive function for this, k is 2 in this case, but k does not go down. For differentiation, k goes down. For primitive function, 1 over k goes down. And then function repeats itself. For the next one, the k is minus 1, so minus 1 goes down, and the function repeats itself. For the next one, minus 4 goes down, and the function repeats itself. And then just a little bit of simplification, this becomes 1 over 2e to the power of 2x, and then I have minus 2e to the power of minus x minus 1 over 4e to the power of minus 4x. So the reason that I am not putting c here, because they have asked for a primitive function, and I can simply choose c equal to 0, that's the simplest choice. Yes? Okay, for example, number 5, f of x is equal to for example, let me just make it simple 1 over pi to the power of 3x. We want to find the primitive function for this function. So what should I do?
You flip it and
Yeah,
put
you
it in the
flip
other
it
side.
up. So the first step is just to repeat this function. So we flip it up, it becomes pi to the power of negative 3x.
Yeah.
And then, this is today's lesson. Which row will help me to do that? The last row here, yes? Why? Because if you compare this one with that one, a is pi in this case and k is minus 3. Then you can immediately write capital F of x is equal to what is happening? 1 over k is minus 3 ln of pi, and then the function repeats itself. Yeah, this is not something we can make it more simpler, so we can call it here. Yes, as simple as that. But if you don't, because first of all, don't take these things. So you need to teach yourself to remember these things. Of course, I have given you this lesson, and of course, every example that I write here is somehow related to today's lesson. But in the exam, that is up to you to decide which one is which. Yes. Okay, so let me just give you another example. What happens here? Number 6, and this would be the last example here. F of x is equal to, so let me write e to the power of x minus e to the power of minus 2x to the power of 2 divided by 3 e to the power of 5x. Okay, I want to wait a little bit for you to see how you act here. And then there is one lesson I want to talk about the primitive function, which is the next lesson in the book. And then, if we have more time, you will practice on yourself. Okay, so I give you 5 minutes to think about this problem. Okay, thank you. Okay, could you solve it? Almost. Okay, I can give you a little bit more. Okay, but let me just solve this one, and then we can continue to the final part of this in today. So here, the first thing that you have to do, you have to simplify. You can change the form so that you can use these or those generic rules. The first two, not these two, they are not rules actually. So what we have to do, we have to expand the first one squared 2 times the first one times the second one. So if you don't mind, let me write everything in detail here. And the second one squared. And then divided by 3 e to the power of 5x. Yes? There is one product here that needs simplification. So let me just continue. E to the power of 2x. And then this one, it becomes minus 2 e to the power of minus x plus e to the power of minus 4x. And then divided by 3 e to the power of 5x. Yes? And then you cannot find a primitive function for this and a primitive function for this and simply divide them, because I have written this is not correct. But what you have to do is to find, so we talked about these problems, these type of problems before, so that I have one single term in the denominator. And if you haven't forgotten, that is just to separate them. Yes, the next one also the same. And the next one the same. But then the rest of it I think you know, yes? Here I have a third, so I just write 1 over 3. And e to power 2x, e to power 5x. So it becomes e, I write 2x minus 5x. The 2x minus 5x has a better name, yes? That's this one. So this expression is nothing except this. And the next one is minus 2/3. And then you can do it in your head. What's the answer? E to power minus x divided by e to power 5x.
Minus 6x?
Minus 6x. So it becomes e to power minus 6x. I'm just doing the same thing. And finally, the last one is a third. What is this? E to the power of minus 4x divided by e to power 5x.
Minus 9x.
Minus 9x. Now everything now is ready. Because the function is no longer a fraction. A minus 9x is no longer a fraction. Yes? So this is actually an expression with a multiplicative constant, but that rule applies here. You see, I have a constant multiplied by my function. I can pull the constant out and just find a primitive function for the function. And that's the same thing. All of them are of the same form. So what I do, a primitive function is, I have 1/3 here. That is this constant that I wrote here. But then I need to use this formula for that one. For each one of them, actually. So minus 1/3, minus 3 goes down, but in its reciprocal form. And then my e to the power, the function repeats itself. Then I have minus 2/3. 1 over minus 6 goes down, and then I have the function repeating itself. And finally 1/3. 1 over minus 9 goes down, and the function repeats itself. And because I'm interested in a primitive function, I don't bother to put c there. And then a little bit of simplification. F of x is equal to minus 1 over 9 if I multiply these two numbers. So if I multiply these two numbers, it becomes first of all positive, and 2 and 6 are simplified. 3 and 3 becomes over 1 over 9 e to the power of minus 6x. And then this becomes negative 1 over 27 e to the power of minus. So that's the answer. Yes.
Would it be possible to multiply everything by 3
No.
before you put them into
No.
primitive function?
No, be careful. You are not allowed to change. If I give you a, if I give you 1/3 of a, you cannot simply multiply it by 3. 1/3 of a is 1/3 of a. If I have a third of crown, I would love to be able to multiply it by 3 and make it 1 crown. But that's not possible. Is that? And that's the same story. But if my money is equal to your money, then 3 times of my money is still equal to 3 times of your money. That is the logic of multiplying something. Yes? Otherwise, why should we stop with 3? We can multiply millions, yes? And then I don't need to teach any more mathematics to live. Yes? Okay, but in our dreams we can do that. Okay, so I think you will never forget about it anymore, yes, Gustav?
Hopefully.
So if you have equality, then of course you can multiply both sides of the equality and make sure that the equality still holds. But if I have one expression, so if you multiply 3 here and there, that is possible. But that is not good because they are not asking for 3 times of a primitive function. They are asking for a primitive function. But yes, if you want, you can multiply both sides by 3. But not just this one. Yes? Okay, now let us go to the last part of today's lesson and talk about this there. They have written primitiva funktioner med villkor. Villkor means conditions, yes?
Yes.
So this is the lesson that we want to teach today. Sometimes they give you extra piece of information and they ask you for the primitive function. So let me just start with a simple example here. So if you don't mind, let me just clean this board. Okay, so let me start with an example. So example, determine the primitive function f of the function f of x equals to, so let us say 5x to the 4 plus x squared minus e to the power of 2x. So you see I am emphasizing here on the word there. If I stop here, that is not correct, because you realize that I cannot ask you about the primitive function because I have 1 degree of freedom, yes? But when they say determine the primitive function, they have to give you extra pieces of information somehow. So determine the primitive function capital F of this function such that f of 0 is 5. So you see, when they ask about the primitive function, they cannot just stop there. They have to give you extra piece of information, yes.
How does the word "the" work in other languages? Because not every language has the word "the." So
Yeah, they have it. Even in Swedish you have something like that.
Yeah, but not every language does. So is there another name you could give it?
So let me see in Persian. Yes, in Persian we can also refer somehow to this.
Yeah, but I don't. I know Polish.
But then you need to go and ask them how they study mathematics. Because whenever something is unique, you should be able somehow to refer to it in a unique way.
Yeah.
Yes? That's a good question, I don't know. But if you have an example, we can see.
Because like I know Polish, and I don't think there's a direct translation for "the." Maybe. I'm trying to think of one.
Den.
Polska.
Ja, men det finns ingen equivalent för den
The
idén.
only.
No, the only is not exactly serving exactly like the.
Yeah.
I don't know, but that's a good question. We need to think.
Maybe you
But
could
I think
say,
in any language you should be able to refer to something like that, yes?
couldn't you say like determine a primitive function such that f of 0 equals 5? Because you still have
Yeah,
that
in
extra
English
information.
it's not correct to say like that.
Yeah,
Determine a primitive function of f such that this.
But maybe that would work in other languages.
Yeah, might be. Okay, I think in English it is not correct grammatically if you write determine a primitive function of f such that f of 0 is equal to 5.
I think
It's not wrong, but it is referring somehow they might be more than one.
Yeah.
So that's also correct.
It's
Here,
not as
in principle,
specific.
if I say there,
There's
I'm
one.
giving you a guide that there is only one unique problem, a function like this. But even in English, when I say determine a primitive function, it means that might be there are others, and I'm asking for one. But if it is unique, that's also okay. Yes, might be that one. Yeah, you're right. Okay, but let us try to see how it works here. So, the first part is finding all primitive functions. Even though they are asking about the primitive function, you find all of them first. Yes? How? Yeah, because this is a simple problem. I just write capital F of x is equal to. What is a primitive function of this one? I can do them separately. Why? Because they are addition or subtraction. And for addition or subtraction, I can do them separately. But for the first two needs this formula. The last one needs this formula. So I have 5 here. This is 4, so it becomes 1 over 4 multiplied by 1 over 4 plus 1, x to the power of 4 plus 1. The next one plus 1 over 2 plus 1, x to the power of 2 plus 1. And today's lesson we learned that the reciprocal of this number goes down, and then it becomes what? 1 over... Yeah, if you don't mind, I forgot to give you this type of example. So let me make it 1/2 here. To also have these kind of problems, yes? So then it becomes 1 over 2, which is 2. But e to the power of 1 over 2x. But then you have to write this constant c for the time being. Even though they are asking for the primitive function, you have to start with all primitive functions and fine-tune this capital C so that the next condition is met. Yes, that's the whole point. So before doing that, let us just simplify things a little bit. This becomes 5 in the denominator and 5 in the numerator are gone. So this becomes x to the power of 5. This becomes a third, x to the power of 3. This becomes minus 2 e to the power of 1/2 x, and then plus a constant. Okay, but the answer to this problem is not this. You have to use this to find c. What is the meaning of this? It means that if you go to your capital F, which is this function, and replace x with 0 everywhere, the answer is supposed to be 5. Yes.
Should C be 3 then?
Let us calculate. Okay. Instead of x, I put 0. F of 0 is given to be 5. Yes, so I put x equals to 0 here. And then this becomes 0 to power 5 plus 1/3 0 to power 3 minus 2 e to the power of 1 over 2 times 0 plus c. Okay, 5 is 5. This is cancelled, this is 0, this is 0. But what about this one?
2 minus 2.
Minus 2. So it is minus 2, but there is a constant c at the end.
So 3%.
But c is 7.
7 actually.
Yes? And then when it's c is 7, you have to write the answer. Because the answer is neither 7 nor this. The answer, you have to plug c here and write the answer. So f of x is equal to x to the 5 minus plus a third x to the 3 minus 2e to the power of 1/2 x plus 7. This is what you have to provide as the answer. Yes? So it means that we were able to not only find a primitive function for this one, but we also found it in a way that it satisfies this extra condition. Yes? Okay, let me give you one more example and then we are done. so example, this is A-level problem, according to what you see in the book, but let me just write it from myself. So, determine the function f, little f, such that f double prime of x is equal to 2x3 plus 5x minus 2, and such that f double prime is this: f prime of 1 is 3, and f 0 is minus 7. Yeah, hopefully it will work. I just wrote the numbers randomly there. So this I will consider A-level question here, not because of the algebra, because of the concept. So here I have given you a function, not its second derivative is given, and I have provided 2 extra pieces of information, and I have written the function f. Somehow I am referring that this function is unique. Okay, can you tell me what to do?
Find the f prime first from.
Okay, so if you do one primitive process, primitive function process, you will get f prime. You do it once more, you get f. So I told you that the process of finding primitive function is the reverse operation of differentiation. So how did I get to f double prime? I had a function once a day, yes. Once upon a time there was a function, yes. And then I got a differentiation. I got f prime, and I did it once more, I get f double prime. The process of primitive function is in the reverse order, yes? So I go from here to here by primitive function. I go from here to here again by primitive function. Yes? So that's the operation that I need to do. This is not part of the solution, I'm just drawing it for your illumination. But what I want to do, so f double prime is this. So I write f prime. F prime, I have f double prime, I want to go back to f prime, so the process is finding a primitive function. So what should I write? F prime of x becomes equal to, can you do these things in your head? Or
No.
not? What's the answer to this one?
Half of x to the power of 4.
Yes, because this becomes 1/4 because of that, but there is a 2 here, so it becomes 2/4, which is 1/2. X to the power of 4. The next one is
5 over 2 x.
5 over 2 x squared. The next one is
2x.
minus 2x, but you shouldn't stop here. You have a constant. Yes? Okay, but there is a constraint for the derivative. The derivative at 1 should be 3. So I use that piece of information right away here. F prime of 1 is supposed to be 3. What does it mean? It means that if I replace x with 1, the answer is supposed to be 3. So if I replace x with 1, so let me write it for the future, if you want to refer to your notes. Minus 2 times 1 plus c is supposed to be 3. Is that understandable? So I replace x everywhere with 1. The answer is supposed to be 3. And that is immediately enough for me to find c. Yes, let me just do some calculations. This is 1, this is 1. 1 over 2 plus 5 over 2 is 6 over 2, which is 3. 3 minus 2 is 1. So this means that 1 plus c is 3, and then I found c. c is 2. When I know c, I put it back into the derivative. Derivative is now found completely, yes? So what is the derivative? So therefore, f prime of x is equal to, what is f prime of x? Is the whole expression plus c, and c is 2. So this becomes 1 over 2 x to the 4 plus 5 over 2 x to the 2 minus 2x plus 2. This is the derivative of my function completely determined without any degrees of freedom. Here, I cannot say that I found f prime because still I don't know c. But after using that piece of information, I found tune actually c, and I know that c is 2 in this case. But the problem doesn't ask you for derivative, asks you for the function. You are here, you go one step back again. So what should I do? Now tell me, what is f of x? I have to do that process of primitive function again here. So can you do it in your head again?
1 over 10 x.
1 over 10, yes? Because this becomes 1 over 5, and isn't a 1 over 2 here, it becomes 1 over 10, x to the power of 5. The next one, in your head,
5 over 6 x to the power of
5
3.
over 6, understandable for everyone, yes? This becomes 1/3 according to that formula. And then 1/3 multiplied by that is 5/6 and x to the power of 3. And this one,
1 over 4 x to the power of 2.
No. I made a mistake at the end. Not 1 over 4, why 1 over 4?
Yeah, that would be 1/2.
So here you have minus 2. This is x to the power of 1. So this becomes 1 over 2, x to the power of 2. This and that are cancelled. So it's minus x to the power of 2. But plus a constant. Because I have already used letter C there, change the name of your letter to something else. And because D is there, it is a little bit confusing. So if you don't mind, let me write C prime, whatever it is. And prime is taken by the derivative. I don't know. Let us write E.
Okay.
And this is not physics, otherwise E is not good because E means energy, yes? But here in mathematics, we don't need change.
Wait, why don't you use C again?
No, because if I use C, this is the assumption that when you use the same letter in the same problem, that letter should be the same number all over again.
Oh, okay.
But there is no guarantee that this number that I get is that number.
It indicates that it's a constant. Just like use another letter for it.
Yes. I mean that if you want to be strict, you have to use another letter. If you use the same name, it means that you have already decided that these numbers are the same. Yes, but we don't know. But if I choose two different letters, it doesn't matter. It might happen the case that they are the same. But if you already choose them the same, it means that you already somehow know that they have to be the same. Okay. And now that is E is not found yet because this is why they have given you another piece of information. And then what does it mean? It means that if I go to my function, replace E x with 0, the answer is supposed to be 7. And that's clear. If I put 0, so let me write for future references, 0 to power 5 plus 5 over 6, 0 to power 3 minus 0 to power 2 plus E is supposed to be 7.
I think it's minus 7. F of 0.
It's minus 7 here, thank you. In the problem it has mentioned it is minus 7. Okay, and then everything is cancelled, E is minus 7. But you shouldn't stop here. What you have to provide as the answer is this expression where E has been replaced by minus 7. So the answer that you have to provide is that little f of x that you were looking for is 1 over 10 x to the power of 5 plus 5 over 6 x to power 3 minus x squared minus 7. So this is the final answer that you have to provide for this problem. Any questions? Okay, good. So you have nearly half an hour. I will update the Google Classroom in case you want. I would prefer you to work on these and lessons, but that's up to you if you want to work for the exam as well. Okay, so I will stop here and I will update the Google Classroom in 2 or 3 minutes. Thank you.